In this video, I'm going to talk about eBGP neighborship conditions. And this means that which condition should be met to eBGP neighborship can be established, and after that we can use BGP for advertising networks or subnets. Look at here. In this scenario that I configured before, R1 and R2 and also R2 and R3 now are neighbors. Let's check it. In R1, I can use the show run, for example. You can see here in the R1, router BGP 65,000 and then neighbor 10122, that is the IP address of R2, remote AS 65,001, that is the remote AS number or the AS number of R2. I configured before, and we configured it in the previous video. And also we can check R2 show run. Look at here, show run router BGP 65,001 and then neighbor 10121 remote AS 65,000 and then neighbor 10233, that is the IP address of router 3, remote AS 65,002. Finally, in R3 show run, it shows us that router BGP 65,002 in R3 and then neighbor 10232 remote AS 65,001, that is the IP address of the R1. Now we have neighborships. Let's check it. In R1, I use the new syntax of commands for monitoring show BGP IP v4 unicast summary. Okay, you can see that R1 now has neighborship with R2, and in R2 I use show BGP IP v4 unicast summary, and also in R2 we have two neighborship between R2 and R1 and R2 and R3. Finally, in R3 show BGP IP v4 unicast summary. Okay, R3 now has neighborship with R2, but the question is what situation, what condition should be met to neighborship between R2 and R3 can be enabled and can be established, and after that we can use that neighborship. Look at here. In BGP we should meet 4 conditions to neighborship can be established. Neighborship BGP neighborship conditions, or eBGP neighborship conditions, but many of these terms about iBGP is also true. BGP neighborship conditions. Okay, let's check it. When you configuring, for example, in this scenario, R1 and then R2, R1 and the subnet between them 10120/24, as you saw, I configured the router BGP 65,000 AS number of R1, then neighbor 10122 remote AS 65,001, and then I configured in R2 router BGP 65,001 neighbor 10121 remote AS 65,000. This is the configuration of R1, and this is the configuration of R2. Okay, and also R1 is in the AS 65,000 and R2 is in the 65,001. Okay, very good. When you configure these commands, R1 after TCP session establishment sends an open message, a BGP open message, okay, to the R2. You saw this message before. In the open message we have some conditions that should be met, and finally R2 and R1 can be neighbors. Which condition? First, the configured remote AS number, should same as actual remote AS number. Actual remote AS number. What does it mean? Look at here. It's so easy. The open message was sent with the source IP of 10121. That is the IP address of outgoing interface of R1 to R2. And the destination is 10122. Okay. In the open message, R1 sends its AS number. It says my AS is 65,000. Okay. When this open message receives in the R2, okay, R2 first check the source IP of the packet and understand that the source IP of the packet is the same as its neighbor command. We configured in R2 neighbor 10.121, and now R2 sees a message from that IP address. And also R2 checks the AS number that configured before in R2 with the AS number received in the open message. And it can understand that the configured remote AS number is equal with the actual remote AS number that is sent from the R1. This means that both of these two parameters are important. First, the IP address, and second, the AS number. And you can see that here I wrote configured remote AS number. This is the configured remote AS number. We should be equal with the actual remote AS number, and this is the actual remote AS number. When R2 receives an open message with the source IP as the IP address configured before in R2, and also with the AS number that before configured in the remote AS number, it can inform or ensure that the received open message is received from the authorized or correct neighbor. Because of that, accept it. This is the first condition should be met for the neighborship. Configured remote AS number is equal to the remote AS number. The second condition is not equal BGP router ID. Not equal BGP router ID. But what is the BGP router ID? In BGP, we use BGP router ID as an identifier for every BGP speaker or BGP router. The BGP router ID's function is same as the, for example, OSPF router ID in OSPF or eIGRP router ID in the eIGRP. How router ID defined for a router or a speaker in the BGP? It's same as the other protocols. BGP router ID is a 32 bits identifier, and we write BGP router ID same as an IP address, but it's not an IP address, okay? The format similar to the IP address, but it's not the IP address. And you can configure the router ID with this command, router config router in the BGP router ID, and then A, B, C, D. And if you didn't configure router ID, automatically router ID selected from the highest IP address of any loopback interface that in the router, highest IP address of loopback interfaces, that should be up, okay? And if we don't have any loopback interface in this router, the highest IP address of non-loopback interface will be our router ID. Highest IP address of non-loopback interface, for example, physical interfaces, that should be in up state. The first has higher priority, and then second, and then third. Finally, we have a router ID for every router. Look at here. Now, for example, in R1, I don't configure router ID. I didn't configure router ID. And as you know, we didn't have a loopback interface. Because of that, the highest IP address of non-loopback interface should be selected as router ID. In R1, the highest IP address of non-loopback interface is the IP address of ETH00, and that is 10.121. We can check it. Look at here. In R1, you can see that in show BGP IPv4 unicast summary, the first line is BGP router identifier 10.121. What is